Hi, welcome. Today's lesson is on limiting reactants, and this is part 2, so if you haven't watched part 1 yet, please go back and watch that. Remember from part 1 that limiting reactants are the reactant that runs out first. So if you have one that runs out, you also have a reactant that you have extra of. And this is what we're going to concentrate on today's lesson. How much excess do you have? Why do we care about excess in chemistry? Well, that's because often we want to minimize waste. As a scientist, you may also want to choose which one is limiting and which one you have in excess. If you want to completely react the sulfate in the cement like we will be doing later, then you want to make sure that is the limiting and not the excess reactant. If your chemical is very expensive, you do not want to have a lot of excess of that chemical. Or if it has a lot of waste or hazardous waste, then you don't want to have a lot of excess of that chemical either. So how do I go about calculating the excess that I have? Well, if you recall from the previous video, we're talking about this specific reaction here, when hydrogen reacts with oxygen to form water. We did this in our little rockets that we launched in the hall. And sorry, I don't know what happened to our arrow here, but there should be an arrow. And the question we asked in the first video was how many grams of water can be made from 38.9 grams of hydrogen and 45 grams of oxygen. So we taught you how to do the math for this. We're going to solve this problem twice. Once with the 38.9 as our starting point, and once with the 45 grams of oxygen as our starting point. And when we did that, we found we could make 50.7 grams of water from the oxygen number, and you can make 348 grams of water if you had reacted all of the hydrogen. We also learned that when you have both reactants, you can only make the least amount because then that reactant is going to be used up. It is the limiting one. So after you make 50.7 grams of water, all of the oxygen is gone and the reaction stops. You can't make 348 grams of water because you don't have enough oxygen. So oxygen is limiting and hydrogen is in excess. But what if I want to know how much hydrogen was actually used? I know it's less than what I started with, but how much less? I just use another unit analysis problem to solve that. So I'm going to solve for grams of hydrogen, but what is going to be my starting point? I had 2 starting points before. So what is going to be my starting point for this reaction? It is going to be the limiting reactant because I know that I used 45 grams of oxygen. That is all used up. So I know this is a good starting point. And then I'm going to work my way until I get to grams of hydrogen. So we're going to just use our unit analysis methods and go from the limiting reactant to how much hydrogen we actually used. And when I do the math this time, I come with 5.67 grams of hydrogen reacts with 45 grams of oxygen. So anything over 5.67 grams for this experiment is in excess. So how much hydrogen is left over? Well, I know how much I started with, and I know how much I used, so all I'm going to have to do is subtract the 2. So I started with 38.9 grams of hydrogen, but I just calculated that I only need 5.67 grams of hydrogen, so I have 33.2 grams of hydrogen left over. So let's review those steps. The first thing we did was find the limiting reactant and the excess reactant, and we did that in part 1 of this video series. Then I found the amount of grams I actually used, starting with the limiting reactant and using unit analysis. And the third step I did was I found the amount that was actually left over by a simple subtraction. I knew how much I started with, I knew how much I used, and then I subtract the 2, and that will tell me how much is in excess. If this is a very large number, as a chemist, I'd probably be concerned. And so you may want to look at that amount if you're running an experiment. So there you have it. How do we figure out how much excess we have? These are the steps that you need. So we'll try some in class, and thanks for listening.